Imagine you are on a skateboard facing a solid brick wall. You reach out and give the wall a firm push. You don't move the wall. Instead, you suddenly roll backwards away from it. Even though you are the one doing the pushing, it feels like the wall pushed you back just as hard. So, here is a real question. If the wall pushes you exactly as hard as you push it, why does only you move? Hello everyone, I am Dr. Zab. I am a UK certified science teacher and a PhD degree holder. I am on a mission to make science click for you. I turn your hardest topics into your easiest wins. So let's break it down. To understand why you roll away from the wall, we need Newton's third law of motion. This law tells us that a force isn't something an object has. It's an interaction, a mutual action between two things. Think of it like a handshake. It needs two people. Newton's law states, for every action, a force exerted on an object, there is an equal and opposite reaction, an equal force pushing back the other way. That one interaction between your hand and the wall actually creates two separate forces. Here's a common misconception: since these two forces are equal and opposite, shouldn't they just cancel out to zero? No. And this is the part most people get wrong. Action and reaction forces never cancel because they act on two different objects. Your push acts on the wall's push acts on you. Since that's the only force acting on your body, you're the one who goes flying. The wall doesn't move. It's basically glued to the entire earth, and the earth isn't going anywhere for you. Let's make this official. Newton's third law formally states, whenever one body exerts a force on a second body, the first body experiences a force equal in magnitude and opposite in direction to the force it exerts. We call these action-reaction pairs. And there's one rule you can never break. The pair must always be the same type of force. If the action is a contact force, the reaction must be a contact force too. Watch what happens when you walk. Your foot pushes backward on the ground. The ground pushes forward on your foot with equal force, and that's what propels you forward. Now take that idea into space. This is exactly how rockets fly, where there's nothing to push against. No air, no ground, nothing. The rocket engine pushes exhaust gases backward. Those gases push back on the rocket with equal force, a forward pushing reaction we call thrust. We write this relationship as force of A on B is equal to force of B on A. The negative sign just means opposite direction, so don't panic about it. It's simpler than it looks. Let's see this play out in the real world. Think about a tug-of-war. Two teams pulling on a rope. You think the winning team is pulling harder? But here's the twist. The rope doesn't stretch more on one side than the other. It feels the same exact tension at both ends. That's because you can't actually pull a rope harder than it pulls you back. So, how does anyone win? The winning team isn't beating the rope. They are beating the ground. They dig in, push harder against the earth, and get a bigger reaction force back. The trick to winning tug-of-war isn't pulling the rope. It's picking a fight with the ground. Let us now consider a hovering helicopter. When it takes off, you feel a massive blast of wind slamming into the ground. But the pilot didn't push some wind button. They just spin the blades. This lift is purely mechanical interaction. As the blades spin, they are tilted to force air particles downward. Newton's law tells us as the blade pushes the air down, the air pushes the blades and the whole helicopter up. The helicopter isn't climbing the air like a ladder. It survives by throwing enough air at the ground that the air has no choice but to throw the helicopter in the sky. Newton's third law doesn't just apply when things touch. It applies across empty space too, through gravity. Take the moon and the earth. We usually say the moon orbits the earth like earth is doing all the work. But that's only half the story. The earth pulls the moon towards it, and the moon pulls back on earth with an equal and opposite force. You can actually see the proof of this every single day. It's the reason we have tides. It's physical evidence of a real handshake between two massive objects. Even without contact, the pair still holds. So next time you push a wall, pull a rope, or launch off the ground, remember, the universe always pushes back. That's Newton's third law. And now, you don't just know it, you feel it. If this video made physics click for you, hit like. Because it tells YouTube to show this to someone who is stuck and hating physics right now. And subscribe, because we are breaking down one impossible topic every week. I am Dr. Sat, and see you in the next video.